Did you know that Scorpios are more likely to jaywalk? Really? Probably not. Today, we're going to talk about data fishing. Let's say we wanted to know if Scorpios really are more likely to jaywalk. How would we test that? One way is with hypothesis testing. We're going to form two hypotheses. We'll have the null hypothesis, the claim that the effect being studied doesn't exist, and the alternative hypothesis, the claim that it does. So in this case, our null hypothesis is that Scorpios jaywalk at the same rate as everyone else, and the alternative hypothesis is that they really do jaywalk more often. The next step is to gather data. We'll conduct a survey of people in both groups. Then we'll use that data to generate something called a p-value. P-value measures the probability that any difference between the two groups was caused by random chance. Finally, if that probability, that p-value, is below a certain threshold called the alpha level, we call our findings statistically significant, and we can use it as evidence to reject our null hypothesis. So if our p-value was 70%, our result would support the null hypothesis. Any difference between the two groups was probably just random chance. If our p-value was 1%, we had evidence to reject the null hypothesis. Find a crosswalk already, Scorpios! Our p-value of 85% suggests that no, Scorpios don't jaywalk more than anybody else. So what's the problem with this test? Well, we only tested one trait, being a Scorpio. What if we tested 50 traits? If each trait has a 5% chance of being found statistically significant, we'll almost certainly find one eventually. Hey, look at that. This p-value is only 2%. We have evidence to support the claim that lefties are more likely to jaywalk. That doesn't seem right, does it? What I just did is called data fishing. I didn't actually hypothesize that southpaws are more likely to jaywalk. I just went fishing for interesting results. It's pretty obviously bull, and it's really important that we don't draw conclusions this way. Our example was harmless, but what if we were looking for risk factors for diabetes? New study, chest hair linked to diabetes. So how can this be avoided? One method is split half validation. We'll take our data set and randomly split it into two groups, A and B. If our finding really is statistically significant, it should be apparent in both groups. Ultimately, we just have to remember that hypothesis testing is only one piece of the evidence puzzle, and that the statistical significance of any set of data is a property of both the data itself and the methods used to test it. Otherwise, we could use hypothesis testing to prove just about anything. Huh.